So for Module 6 of Lecture 4, we're going to look at the last conditional statement that we'll consider within this lecture, which is the for loop. So for loop is pretty simple. If you have a code block and you want to repeat its execution for a fixed number of times, it's the control structure that you want to use, unlike a while loop, which allows you to repeat execution until a condition is met. So for is for repeating execution of a code block for a fixed number of times. The syntax is pretty simple. You have your keywords for and end. You put your code block in between the two keywords. Best practice is to indent it just to make it readable, even though it doesn't have to be indented. The little bit of difference here is since you're executing for a fixed number of times, you just don't use some logical value within here. You actually need to define what's known as an indexing or looping variable. You can actually pick whatever identifier you want. By best practice, you keep this short. Usually it's a single letter. Things like I, J, or K, or M, or N. And the reason I said all those different indexing variables is oftentimes code will have multiple for loops in it, and you don't necessarily want to repeat the same indexing variable. And even more complicated, oftentimes you will have what are known as nested for loops, where one for loop is within another. But pick your identifier, usually a single letter here, and then you define the range of values for which that identifier can take on. And we're using our colon notation from when we introduced the idea of equally spaced arrays. You'll notice that we only have a first and last value, meaning that it's going up or incrementing by 1. And this is just saying that my indexing variable, whatever I call it, can take on values between 1 up to stepping by 1, whatever the maximum number of iterations is. And each time that it's within that range, the code block will execute. The second that it goes out of that range, code block doesn't execute anymore. So say your indexing variable was called K, and you had number of iterations set at 2. The way that this works, as the interpreter is going to execute, first time it will define K as 1. It will execute the code block since 1 is in this array. After it hits the end statement the first time, it will increment the indexing variable to 2, in this case K. Since 2 is in the array from 1 to 2, code block will execute. When it hits end, it will increment the indexing variable to 3. Since 3 is outside of this range, the code block won't execute, and that's the end of the for loop. So that's how a for loop generally works. So let's actually look at an example here of how we can create an array of 5 random integers ranging from 1 to 10. We want to use the randi function in this case, and then print each to the display using the display function using the for loop. So this is actually like a not great way to do this problem, but I actually want to show you just because it's an easy starter example of working with for loops. So we want to repeat 5 times. Let me actually write what we're doing. Generate a random integer between 1 and 10 and print to the screen and repeat 5 times. So we'll start with the easy part. Since we know we need to repeat a conditional execution block 5 times, we'll put in the keywords of the for loop, for and end. We'll define our indexing variable. I'm going to call mine K. I want it to run from 1 to 5 because I'm repeating this 5 times. Then what I want to do is generate my random value. Now you might say that randi can actually be used to generate an array of values, and that is exactly true. You can totally do that, and if you do that, it's actually more efficient. I will kind of maybe give you an example of that, why that is on the homework, actually using the tick and tock command in order to time the execution of your code. However, for now, I want to kind of introduce a new concept to you. So I'm going to call this value that I'm generating random vals. So if I just actually stored the random value that was generated, which will naturally be between 1 and 10, if you remember how the randi function works, in randvals, let me actually just show you this, and I'll prove it to you by running this, and I'll call this example 2, 3, since I've already used 2. If I execute this, what do you think will happen? Well, since I have a for loop with an indexing variable ran from 1 to 5, I will execute this command 5 times. And since I don't have it terminated by a semicolon, it will actually spit that value out to the screen. So let me show you how that works. So if you notice in this case, it's actually generating 5 different random values, but each time it's overriding the value that was in the random value variable. So notice what happens, and this is kind of something that it's not a good practice to do, but I just want to show you. This is actually called popping a value on to an array or vector in computer programming languages. So what will this do? Well, the first time, and I'm going to clear all just to if you do this without using clear all, you'll see why I actually cleared all. But what this will do is MATLAB will basically pop a value onto the array each time that the looping variable increments or goes up by 1. So the first time that this code runs, ranvals1 will create an array of a length of 1, and in that first element, it will put the random value that is generated. Once it goes to 2, it will, in the second element, put the random value that is generated, and so on and so forth 5 times. And I can kind of prove that to you by just running this. And if you notice, it is each time that it's displaying through the loop, it's actually popping a value onto that array. So that's part of what I wanted to do, is create an array incrementally that where I'm storing the value of a random value that I generated, but I also wanted to display it each time. So if I were to do that, I could just use the display function. Make sure you're just displaying the kth value of ranvals, which is the one that you just generated. I'll clear the screen just to make this easy. I'll clear everything so you know that it really works, and I'll execute it again. And if you notice, what it's doing is it's printing out the value that's randomly generated each time, 22416, but it's actually storing that in the array as well. So you might, if you remember what we talked about before in the last lecture, just ask yourself, well, why wouldn't you just generate a random value vector using randi and make it go up to a maximum value of 10, but actually generate the entire array of 5 in a single operation? And you definitely can do that. And I'm going to show you how that would run here. So if you notice, I commented out the 2 lines of code that I was using originally, where I was generating the random value each time and displaying it. Instead, now I'm generating the vector outside of the loop, and I'm just displaying each time. So if you notice, this code actually works the same way. It's just showing you that there's 2 different ways to do things. In general, MATLAB, if you remember the name of it's kind of a shorthand for matrix laboratory. So the more preferred and quicker way to do it is to use vector operations wherever you can. So if you actually see this, I'll show you. If you clear all and close all, you'll notice it's giving me a bit of an underline here. And it's what it's telling me is that ranvals appears to change size on every loop iteration. Consider pre-allocating for speed. So when you run a script and you actually pop values on to an array or vector, because it has to go into memory and increase the size at every iteration, that's not a very efficient way to implement your code. So in general, whenever you can avoid loops or avoid dynamic allocation of memory within MATLAB, it's something that you want to do from a coding best practice. However, I just kind of did this as an example to show you how a very simplistic application of using a for loop within MATLAB, and you'll get a lot of additional practice on your homework this week.